welcome Jeff Clark. We are very excited he was willing to do this presentation virtually. We were supposed to be in person today, but obviously that's not possible. But right now I'm going to introduce Chuck Lauder. He is a Climate Change Coalition Steering Committee member and former Dean of Student Affairs at Lawrence University. And he is the reason why we have the pleasure of Jeff Clark's presentation today. And if you see him under Estella's name, it is just his wife, but that is Chuck. And Chuck, you can take it away.
Good evening, everyone. I'm delighted to introduce Jeff Clark, Professor of Geosciences and Environmental Studies at Lawrence University. Although I'm retired from Lawrence, I overlapped with Jeff for a number of years and have continued to follow his work there and at Bjorklunden. Since you were registered for this presentation, you are aware of his impressive academic credentials, his scholarly interests, and his commitment to the environment and sustainability. Tonight, I want to highlight his approach to teaching, learning, and the development of ideas. In 2005, Jeff taught a seminar on sustainability, the outcome of which was SLUG, S-L-U-G, Students Lawrence University Garden, an ironic name with a great outcome. Jeff was the instigator and first faculty advisor for this volunteer group, which was granted a piece of campus land to establish a truck garden. They used sustainable principles and marketed the produce at the local farmers market. Later, they arranged to sell all of it to the campus food service, contributing to a healthy diet via principle. Students volunteered during term time, and the income provided summer jobs for students who stayed on after classes ended. Now, 15 years later, SLUG continues as a vibrant program with new generations of students constantly engaged. Alums of this activity have gone on to help establish similar community projects such as Riverview Gardens in Appleton. Tonight, Jeff will show us how such a model can be applied to a different project, Net Zero Bjorklunden. He will share the steps and complexities involved in seeking carbon reduction and suggest a variety of approaches to this goal. Jeff's enthusiasm and commitment are infectious and inspiring. Enjoy.
Thank you, Chuck.
Okay, everyone, I'm just gonna share my screen now. All goes well. And okay, are we good? Could I get a nod that you can see the slide? Excellent. Okay, well, thank you very much, Nicole and Chuck, for inviting me. When Chuck first called me about this, I think it was before or very early on in this pandemic. And of course, at the time, we thought we'd be at Bjorklunden, which would have been special. And however, when I accepted, I also realized that what I had was really just ideas. But now some, I don't know, 8 or 9 months later, we actually have engineering plans, and we are actively fundraising for this project. So a lot has happened in that time, and that just gives me a little bit more energy and enthusiasm to talk with you about this. The other thing that I want to mention, I want to thank you all, the Climate Change Coalition of Door County, for sort of keeping the fires burning. There's a lot going on in the world right now, a lot of difficult situations we're facing, but climate change is not going away. And it's going to be there waiting for us when we're through this pandemic. And so we have to continue to make progress and to think about it. And organizations like yours are making sure that that is happening. So thank you for that, and thank you for the opportunity. So I'm going to talk about Net Zero Bjorklunden, okay? And the idea is to move the Bjorklunden property, which I'm assuming you all know, but that's not always a safe assumption. So, you know, it is just south of Bailey's Harbor. It is a 441 acre property that consists of mixed hardwood and deciduous. And there is a lodge over here that is a 37,000 square foot lodge. That lodge was rebuilt in 1996 after a fire destroyed it in 1993. And then an addition was put on in 2006. And again, we would be up there now. The lodge hosts many summer programs, and during the academic year, every weekend, 100 or more students and faculty go up for departmental retreats and workshops and the like. So it's a very special place for us, and it also represents a great opportunity for us to start to understand how we can reduce our carbon footprint. So I want to talk with you first a little bit about the context of this, because it does fit into some larger sustainability efforts that we have going on down at the Appleton campus. And then I'll talk a little bit about why Bjorklunden in particular. And then I'll get into kind of the nuts and bolts of what we're actually going to do there. So in terms of the broader context here, we started our sustainability journey back in 2008. The initiative was called Green Roots. And we developed this mission statement that we still maintain today, some 12 years later, still going strong. And that mission statement is to establish an institutional framework within which we can cultivate habits of mind and dispositions that lead to ecological intelligence and environmental sustainability. And so what we're trying to do is to basically provide a living environment. Now, Lawrence is a residential college, so 95% of the students live on campus and they eat on campus. We can really affect the way they live their lives. We want to provide them with the right tools to make better decisions, not only for when they're on campus, but also from when they graduate and go off to live productive lives after graduation. We've continued these efforts the past 3 years with the support of the Margaret A. Cargill Philanthropies. And the topic of our proposal to the philanthropies was to instill a culture of sustainability by using campus as a living lab. Okay, and that very much harkens back to this. The living lab is institutional framework, and culture is habits of mind and dispositions. So we're trying to maintain consistent in our philosophy moving forward. And I want to give you a couple examples. Chuck has already told you about one of how we can engage students with sustainability. And that is that this idea, this slug garden down here, not only produces food for the dining hall, but also we compost all the waste, all the kitchen waste as well. So there's a nice closed nutrient cycle. Again, it's great opportunities for students to learn how to grow their own food. I believe that people should be able to grow their own food and bake their own bread. These are my little peeves or my goals that I pass on to my students in my classes, especially in environmental studies ones. We also are very supportive of students that come to us with ideas and want to turn those into reality. So some students were noticeably or noticed that our waste and recycling wasn't going very well. You'd have a recycling bin and then a trash can, and everything would be mixed. And so this student did a lot of work to figure out a better way to approach it. Better containers, clearly marked containers with the right tops, so it looks like a can. And we were able to reduce our contamination by about 50% by just changing the way the canisters looked. And that was a student-initiated project. We want to continue to support those. And then we also want to use our infrastructure in classes. So for example, we have 2 small solar arrays on campus. I pull the data right from those arrays and use that in my lectures on environmental science. I can also pull the wind turbine data. There is a 50 kilowatt wind turbine already at Bjorklunden, and I can pull that in and use it as well. So being able to use data rather than having it just be from, some random site, but having it be from right where you're living, maybe on top of the building that you're taking a class in, is pretty powerful. And we want to sort of leverage that as we move forward into our endeavors at Bjorklunden. So why Bjorklunden? Well, there's a few reasons. One is it's kind of the right scale for us at this point. 37,000 square foot building. That's bigger than most homes, I would guess. So it's substantial, but it's not an entire campus, which means that we can kind of afford to approach this project. To do something like this on campus would be $50, $75 million, or just not in a position to do that. But we can make an investment in Bjorklunden and learn through that process, and then take some of the best ideas, the things that worked from start to finish the best, and then implement those back on our main campus as well. But the other reason that Bjorklunden is attractive is that culture piece again. So what you have to understand, now I don't know how many of you have 18 to 22-year-olds in your life, but you probably did at one point. So imagine people coming in and taking off their shoes. That's the first thing the students do. They take off their snow boots, they take off their shoes, and that way dirt is not tracked throughout the lodge, okay? Students sign up for what they call opportunities at Bjorklunden. Students cook. They help the wait staff, or they are the wait staff, and they help the cooks prepare the meals. They do the dishes. They clean public restrooms. They clean, vacuum, and mop floors. They clean their own rooms before they leave, okay? These are things 18 to 22-year-olds do not do on ordinarily. So it shows you that with sort of a cultural expectation, cultural norms can be very powerful. And we want to leverage those at Bjorklunden, provide now even more reason to be green, and see how well we can do on even just conservation from a personal standpoint. If you've been in any of the rooms at Bjorklunden, you might have seen one of these signs. They're typically near the thermostats. These we made back when we started sustainability. And just to justify, we wanted, reasonable temperatures, which are going to be energy saving. Reasonable showers. Okay, I feel as though a 3-minute shower is a little short, but I that's my guilty pleasure, is a little bit of a longer shower. But each person can give and participate in their own way, and this shows a commitment, and we hope to continue that commitment. So why Bjorklunden? It's the right size. There's already a wind turbine there, so we're part way there. And then also it's just a special place, and students think about it differently, and they behave differently up there. Okay. Nicole, any questions come in yet? I suspect not, but.
Haven't seen any yet,
Okay.
but if anybody's interested, please type them in the chat box, and I will let Jeff know, or we can move on and we can wait till the end too. That's fine.
Okay. Yep. So now I need to define my terms and be honest. So what is net zero? Okay, net zero means that when we take our emissions, and we're talking about carbon dioxide here, okay, and then we subtract off whatever we think we can get through conservation efforts, whatever we can produce on site through renewables, and then any sinks that we might access. So if you take those three and you subtract it from the emissions and you get zero, okay, that is net zero, right? As you will see, that doesn't necessarily mean we're matching 1-to-1 for electricity and gas use, okay? Our climate makes that very difficult if you're starting with an existing building rather than building one from the ground up. The other thing I will say is we are defining this as the main lodge. There's the Stauber, there's a couple outbuildings, as well as the studio, there's Door Shakespeare, there are parking lots. We're not really accounting for those, but I believe that what we're doing will actually cover those as well and still be net zero. Another thing we're not really accounting for is people traveling there. So lots of organizations, you can pay or donate a carbon offset, so that if you traveled to this location, you can pay into a fund that goes to, say, preserve forests, and that's supposed to offset the carbon you use to get there. So we don't account for mileage for visitors. We don't account for gasoline for the bus that brings students to Bjorkluden and drops them off either. Okay, so that's a little bit broader of a scope. We might get there someday, but this is a relatively straightforward accounting, and that's what we're going to start with. Okay, so here are our emissions. So this is emissions of carbon dioxide in metric tons. So a metric ton is 1,000 kilograms, and 1,000 kilograms is 2,200 pounds. Okay, just to give you a feel for something like that. And our emissions are about 139 of those through electricity, and 104 through burning liquid propane. Okay, the liquid propane is for heating, and it's for cooking as well. And electricity is pumps and motors for the refrigerators. It's pumps and motors to move air and the radiant floor heating fluids around the lodge. Also lighting, of course. The 104 from the liquid propane, that's pretty standard. I mean, it's pretty easy to measure the CO2 output from burning propane. The 139, that's going to be different from region to region because energy mixes differ. So this is based on WPS's energy, their sources, so there's some coal, there's some natural gas, there's very little in renewables in their energy source. And this 139 metric tons is a reflection of what they produce, when you multiply the number of kilowatt hours that we consume, okay? So that's what we need to tackle, roughly 243 metric tons, okay? And how do we know this? We can just look at our utility bills and see how many gallons of LP and how many kilowatt hours of electricity we use a year, okay? Pretty straightforward. Everyone could do this for their own house. All right, so now we got to start figuring out how to reduce that. And one of the ways is simply through conservation. Now, this is not conservation that necessarily depends upon human behavior. That's maybe another little feather or a little thing we can put in our back pocket. This is actually conservation around energy efficiencies in terms of technology. So although the lodge has upgraded in the past, like 8 years ago, to compact fluorescents, we know that those have their own problems, and we know that LEDs are even more efficient. So completely outfitting the lodge with LEDs, as well as upgrading some of the pumps and motors for the mechanical systems, is going to, we estimate, save about 34 metric tons here. And anyone who's looked at using renewable energy on their own property, maybe putting up solar panels, for example, probably knows that the first step is to figure out how to save as much energy as possible. That's always the most cost effective. If you can reduce the size of your system because of savings, that's going to save you money in the long run. So that's pretty good, that 34 metric tons. Next, we have the turbine that is already existing on the property. That's about 42 metric tons of carbon dioxide a year. That turbine is about 10 years old now, and it needs some refurbishment. So part of the project is going to be to rebuild the gearbox, which is up here, and then also to make sure this base plate and all these bolts and everything are sound and tight. Don't want that thing falling over in the wind. And we think we can get another 10 to 15 years out of the turbine with some directed maintenance at this point. So we're going to keep that running. The lion's share oh, and I'll just mention that this turbine is a 50 kilowatt turbine. It's relatively small in terms of wind turbines. We couldn't go any larger because of county ordinance. And with wind, the name of the game is higher is better, because the farther away you get away from the ground surface and all those trees, the better the wind is, the higher the velocity. And really the power scales quite strongly with velocity. So that's why you see a number of wind towers being quite a bit taller than these, right? I mean, some of the blades of those large towers are taller than this turbine. Okay, so this is relatively small. All right. The lion's share of our production is going to be in solar. Solar is a relatively old technology. It's tried and true. And unlike wind, there's no moving parts. So it's kind of hard to break solar. These are pretty hail resistant these days even. And they last for 20 years and even 30 and 40 years. Their efficiency does drop over time, but they are pretty solid choice. Now you might think, gosh, we're what, 45 degrees north? How good is the solar resource? Consider that the country of Germany, all of the country of Germany is actually north of Lake Superior in terms of its latitude, and they produce about 10% of their power through solar, and it's cloudy lots of the time. We're actually gonna do okay. We're not gonna have to worry about trees because we're gonna put it in an area and we'll be sure to clear the trees around it. So we should do pretty well there. So this 181 metric tons of solar is going to be a fairly large field. This you may recognize as the solar field over at Waseda Farms. This, I believe, is a 50 kilowatt field, roughly, if I just did the math right. Ours is going to be closer to a 200 kilowatt field. And it will occupy about an acre of space. Okay, so the existing turbine is right here. And within the conservation easement, we've carved out what's called a renewable energy zone that's just north of that turbine. And this square is a little bigger than the actual renewable energy zone. We're going to have to make some adjustments there. And the reason we want to site it there is there's a number of them. First of all, there's already an access road, which is great. Second of all, if anyone's hiked around Bjorklunden, you might have come across Turbine Pass, which is a relatively new trail, just 10 years old, winds, oops, I clicked, winds through the woods here and ends up at the lodge. That trail was created by trenching bedrock, okay? So to get power from the turbine to the lodge, they had to trench through several feet of bedrock to be able to lay what amounts to a giant extension cord, okay, where you plug in from the turbine. We want to take advantage of that trench and reoccupy it with all of the connections from the solar field, okay? So we will have to clear some of these trees out of here, but this is already a fairly poorly treed area. It's not like the forested areas here. This is part of land that was cultivated as few as probably 40 years ago. So these are just volunteer trees that have grown up in the meantime. So that's, you know, we're trying to use our existing infrastructure to our advantage. And that makes it an attractive location for us. There are some problems with it. It does get a little bit of shading from the turbine. That's pretty minor. But there is another phenomena called ice throw, where if the turbine ices up in the winter and then starts spinning again and sheds that ice at 100 miles an hour, that could damage the panels. So we're trying to evaluate how significant that risk is as we proceed. Alrighty. So the last little piece of the on-site renewables is geothermal. And in essence, it's not actually really producing any energy. It's more of just reducing energy. use, okay? And anyone who's interested in putting in geothermal in Door County and has looked into it probably knows that it's not the greatest geologic setting for that, because there's typically very thin soils. I mean, you know, how many basements are in Door County? We're talking about what's called shallow ground source geothermal. So we're not drilling down into the mantle or some magma body like you would in Hawaii or Iceland or around Yellowstone. We're just using the ambient temperature of groundwater. And groundwater actually maintains roughly the same temperature as your average temperature throughout the year. So if you, up in Door County, if you took every single day and the temperature every single day, so the average temperature, and then averaged it over the year, it would be around 50, 52 degrees. And that's about the temperature of groundwater, okay? And so we can use that to both heat, to help heat and cool the lodge, okay? Now you'll notice that this 8 is a small number, and there's a few reasons for that. First of all, right now, we're only planning on doing half the lodge with geothermal. The other thing is, because of the way geothermal works, is we still need some liquid propane to boost, to boil water to boost the temperature, okay? So geothermal gets us part of the way there for heating, but not all the way there. And of course, we're still going to be cooking, and we still need fuel that way. So it's not like this great match with our gas use, right? It's actually quite small. The other thing is, although we're saving gas, it's costing us electricity because you have to run pumps to circulate the fluid between your wells and the lodge, okay? So the net is good, but it's small. So for those that are familiar with the lodge, this parking lot here, which is just crushed gravel, it's not actually paved, we'll have a well field installed, probably about 30 or 40 wells. They'll go down into the bedrock, drilled through bedrock. So, you know, this gets expensive. It would be better if we had 10 feet of soil to work with, but you just don't find that much in Door County. Maybe some places in Bailey's Harbor, which is an old river valley that's filled in, you can find deeper soils, but not around here. So we're going to drill into here, and then we're going to run it into the lodge. So here's the parking lot, okay? So we have these wells in here. They have P-TEC tubing, this heavy-duty plastic tubing. We pump water through that, so it's a closed loop. We're actually not extracting water from the ground. We're just pumping water through a closed loop. And we'll, you know, there's either going to be some antifreeze or salt added to it so it doesn't freeze itself. And then that gets exchanged through a heat exchanger. So we can extract heat from that, and then that gets put into the heating system that's in Bjorklunden. And this is just a very, you know, nice aesthetic view of the mechanicals room. So the geothermal system will go in here. I mentioned very briefly earlier that one of the really good things about the way the buildings are heating and cooled is that it's radiant floor heating, and that's a really good system for a geothermal system. So again, the way it works is, so that water is 50 degrees. Now, if it's 70 or 80 degrees out, that's great for cooling, okay? You don't have to do much there except circulate that cold water through your floors, and there's your cooling, okay? You can also basically run it through a version of an air conditioner and turn it into cold air as well. In the winter, you know, 50 degrees is not that warm. I don't think we would be happy with our homes heated to 50 degrees. But if you have 50-degree water and then you don't have to, but it's 0 outside, that's something, okay? And then you only have to heat it up another 20 or so degrees to get to a very comfortable temperature. So that's sort of the principle, is it gets you most of the way there on heating, and in some cases all the way there on cooling. And it's also nice because it can do both, and it can also supply hot water heaters as well. Same principle, right? You're not going to take a 50-degree shower, but if you start with water that's 50 degrees, you don't have to warm it up quite as much to get it to a nice, comfortable temperature for showers. Now, this system is expensive, and we were considering not even doing it. We want to do it for the educational piece because we want to explore a mixture of treatments, again, to learn from them, but also for students and visitors to the lodge to learn from them. So we thought about the question a little more carefully and did what's called life cycle costing. Okay. Now these are actually old figures. They're not the ones we're using today, but they're ballpark enough to give you an idea of how this how this breaks down. So we have two basic options. Again, the older part of the lodge is over 20 years old. The newer part is 12 or so. And so those boilers are getting on to have to be replaced anyway. And replacing them, they would be replaced with more efficient boilers. So replacing the boilers would cost about, let's just say $75,000. A geothermal system is going to be like 10 times as much. Okay, that's kind of a tough pill to swallow. And that was sort of the sticker shock that, that first confronted us. But as we started looking at it more closely, we see that because geothermal uses so much less gas, its operating expenses are substantially less every year. Okay, now, and this does account for the extra electricity too. Okay, so it's substantially less on a year-by-year basis. So over the lifetime of a boiler that's close to 700,000, this is now 350. So we've really started to close the gap a little bit there. Maintenance expenses actually a bit higher for the geothermal because we'll replace heat pumps at year 25. And if you add all these together, over the lifetime of the boilers, you get around $775,000. And over the lifetime of geothermal, you get, let's just call it 1.5 million, okay? So about twice as much. So you went from 10 times as much to twice as much. That's reasonable, but still, this is an awful lot of money for a mere 8 metric tons of carbon. So the other thing you need to do, though, is to figure out how many systems you'd need to have in place. So since boilers are rated to be roughly 20 years, and a geothermal system is rated to last more like 50 years, you'd need to have 2.5 boilers replacements in the time you would have one geothermal system. So if you divide these large lifetime costs by the number of years, you get this breakdown here. And at the end of the day, geothermal turns out to have a better payback, okay? But you got to have the upfront capital in order to be able to make that investment, okay? So that made us feel a little bit better. You know, Lawrence has been around for over 150 years. We hope to be around for another 150 and more. These are reasonable payback scales for an institution. Maybe not for a homeowner, certainly not for me as a homeowner. But for these institutions that have longer you know, time horizons, then that can be useful. All right, so we have our 243 metric tons that we're producing. Through lighting and other efficiencies, we can get 34. We've already got a wind turbine that gives us around 42 metric tons in reduction, a big solar field, a little geothermal system, and then also we are interested in looking at carbon sequestration of the property itself. And this actually is kind of cool too, because I've had students, there's been 4 faculty and probably about 20 students working on this over the past couple of years. So a great way of engaging people in a very practical process. And these are students who are like biology and environmental studies students. They're not like engineers. They like to go out and approach sort of pure science questions, but these are great applications. So what we did last summer is we established about 20 plots on the Bjorkluden property. And we would go out and drive a rebar stake in the ground and then take a tape measure and make an 11.3 meter radius circle. Why 11.3 meters? Because that means that the area of the circle is a tenth of an acre. Okay, this is standard Forest Service sort of protocol that we're following here. And then we went and for every tree that was larger than, I think, 2.5 inches at around chest height, they call it DBH, diameter at breast height, we would measure the circumference. And we'd also figure out what species of tree it was, see if there's any damage, and then we would tag all these trees. Now, in 5 years, we want to come back and measure them again to see how much they've grown. And if you do that, if you see how much wood the trees put on in 5 years, okay, you can convert that biomass into carbon, right? So if you take a dry piece of wood, roughly half that weight is carbon, okay? And that carbon came from the atmosphere, right? So trees are photosynthesizing, they're taking energy, photons from the sun, they're taking water and carbon dioxide, and using chlorophyll as a catalyst, they're creating sugars, basically, that then get turned into cellulose and lignite and wood, okay? And thankfully for us, they kick out oxygen in the process, okay? But these trees are sucking up carbon dioxide every year. And as they grow bigger, that basically you're seeing the storage of that change over time. So we've established these plots, and we want to go back in 5 years and measure them and see what the difference is. But lots of other people have done things like this before, so we can use just some equations and relations that others have worked out to estimate what we think the sequestration would be. So this past summer, and I was just up there Monday of last week, ground truthing this, we added several more sites, and then we've created a map using aerial imagery from some from satellites, some from airplanes from the federal government, and then also we have like a small fleet of drones now as well. So we've flown over these areas too to make this map. And this just shows the different kinds of forest types, because something like the cedar along the shore here actually grows quite a bit more slowly than, say, the pine stands that are over here from some of these old pine plantations. So we need to take that into account. And then we can take the area that's covered by these various forest types and multiply that times the amount of CO2 uptake per acre, depending upon the kinds of trees you have, primarily the difference between deciduous and evergreen, with again, the shoreline firs and cedars being the very small in terms of the amount of carbon they take up. And we can see how much carbon the property takes up, or we can estimate it. What we're really interested in is this stippled area, this yellowish hatched area. That is what we're calling scrub. And that is areas that are really not very well treed at all. So we're thinking if we went in and had a reforestation plan and a forest management plan for the property, we could sequester an additional 16, maybe 20 metric tons of carbon dioxide. So the astute observer will see that this actually adds up to be greater than what we started with, which is good. That's where we want to be, okay? These numbers are actually probably pretty solid. The biggest unknowns are probably in the sequestration piece and probably in the geothermal piece. But we're going to be very, very close in here. So we feel pretty good about this project moving forward. The other piece of this is not just making Bjorkluden net zero, but it's also this educational piece. And as you can see, we're already involving students in the process. I'm actually going to be teaching a class this winter, similar to the one that Chuck mentioned, where we developed the garden, but we're going to be doing this kind of analysis for all of campus. Again, learning as we have along the way from the Bjorklunden piece. We also want to be able to use these data in the classroom. So here's a solar array, and this is just how much energy is being produced on a diurnal basis, okay? So the higher, the more energy. These are solar panels again. So any of this jagginess is just clouds passing by. So we use this in environmental science. Our physics colleagues use it to talk about renewable energy production more from an engineering standpoint as well, because we can back out the watts and the amps and figure out how much, or the volts and the amps and figure out how much wattage there is, and then convert that into kilowatt hours. So they like to use that as well. So we hope to be able to use that as we're teaching. And of course, when people come to visit, we want to have one of these sort of dashboard displays. If anyone's been to Bubolt's Nature Preserve down in Appleton, they have what's called a microgrid. And I had to screenshot this from earlier today because I realized at this time of night it's not going to be producing a whole lot of energy. But what they have is a solar field. They have a battery that they charge, a little a microturbine, which is gas powered, and then they also have what their lodge uses. So at any given time, you can visit a website, or if you're at the lodge, you could kind of see how much is the lodge consuming, and how much are we producing, and is there a balance there? And this where you could have some fun, like student groups could go up and say have contests to see how low a usage they could have over their visit or something like that, and make it maybe a little competition. Who knows? It could be kind of fun. Or groups that are visiting for seminars could do sort of the same thing. So we're kind of excited about the possibilities there. Okay, I think that is good for me, and I'm more than happy to entertain questions if folks want to take a minute and shoot a few to Nicole.
That was great, Jeff. Thank you. I will start. I have a couple questions. I wrote a couple of my own, but I will start with everybody else before it gets to me. I can always email you. We have one from Terry, and she asks, can you use lake water in place of geothermal?
That's a good question. We actually considered laying the loop in the lake, but right offshore is a bedrock shelf, the same shelf that the lodge kind of sits on, that goes out about 150 feet. And nowadays, that's in relatively deep water. But I think you all know that 12 years ago, that wasn't the case. So we would have to go out quite far to be able to access lake water in terms of a loop. In terms of pumping lake water in, that would require special permitting from the Army Corps of Engineers and the DNR, I'm sure. And we also don't want to actually take and use the water and then return it. We have a closed loop that's just going through the water. We never exchange fluids with the environment, and it's a little bit safer that way. Also, it would be very, in the winter, we have to worry about that freezing, and so we couldn't use the lake water because we'd have to add like antifreeze to it basically, and you don't want to return that to the environment. So, but it is a version of that we certainly thought about. I was actually quite excited to use Lake Michigan as our source. There's a high school in Fond du Lac that has a large artificial pond that they use for geothermal, and they just have loops of this of the tubing in the bottom of about a 20-foot deep pond. So it is people do use that.
Great, thank you. So our next question is from Roy Thilly, and he is actually one of the Climate Change Coalition Steering Committee co-chairs, and he has a couple questions, and they're kind of long. So I'm just gonna, Roy, I think you could unmute yourself. You should have that function, and then go ahead and you can chat with Jeff here.
Sure, thank you. And thank you, Jeff. It's a great presentation, and really good to hear what you're doing at Bjorklunden. I had a couple questions. One is whether in looking at the geothermal system, you looked at all at what was done with the Ridge's new building. They did deep wells. When we did that, they don't have the cooking load, they don't have radiant floor heating. It's lighting, air conditioning, and heat, replacing propane. But the numbers came out a lot better, as I remember them.
So where did they have to drill into bedrock is my question.
Yes,
they did.
They
okay.
did. And the folks at Sustainable Engineering, Mangus, I can't remember his name, but he's an expert on the geothermal systems, was surprised at how well it worked. The driller liked it. And the water flow to and from the lake, the movement down, you know, I don't remember, 200 feet, whatever it was very good. Now it's a heat pump system, not radiant flooring, but I know that they were surprised and the economics looked pretty good.
Well, that's great. I mean, yeah, so I just took a few notes down and I might touch base with you. The geothermal piece is probably one of the last pieces we'll do. So we've not procured anyone to do that. And again, these are estimates and gosh, when we had these made, some of the people couldn't even visit Bjorkluden because of COVID. So, you know, they're squishy, I'd say. And usually they're squishy on the bad side, so.
Well, I'd be glad to put you in touch with the people who did it.
That'd be great.
I think. The other question I had is, it's really hard to do the calculations on net zero, and I really like your approach. I was wondering, you've got 139 for the tons of electric consumption. You've had the wind turbine running. So did you take your electric consumption with WPS and then add to it what the wind turbine has been producing?
Yes, that's right. So that is a true measure of our consumption. The turbine will provide 25 to 30% of the lodge under great conditions. So yes, I've backed that out.
Yeah, because the solar should work with it. Normally the wind sort of dies when the solar comes on, but I'm not sure whether that works here. It certainly does in Minnesota and Dakotas. That dies in the morning and the solar comes on. So
yeah, you usually get offshore and onshore winds because of the temperature difference between the lake and the land. It drives the wind. That's right.
Yeah. Okay. Thank you.
Thank you.
Thank you, Roy. Jeff, we have another one from Terry, same as the first one. So Terry, if you can just unmute yourself, we can just do a little back and forth just like Roy did. I think that's okay.
Yeah, that works well.
Oh, yeah, we'll do it too. I'm just curious whether you said there's a limitation as to the height of a wind turbine. Can you get a variance from that? Because, you know, wind, at least in Minnesota, is favored generally over solar because of cost and efficiency.
Yeah, and what we're finding for this scale turbine is it's quite the opposite. In fact, our consultants came in and said, you know, it would be better for you just to take that turbine down and put in more solar panels. And we said, well, you know, we're kind of about sort of teaching about lots of different kinds of renewables, not just a big solar field. But that is largely a function, you're right, the higher the bigger and the more efficient, the more wind you're gonna catch. To be frank, I don't know how aggressively we pursued a variance in that regard. There are also aviation restrictions, which are not, you know, you can't go around the variance there, but I don't think that's an issue with that one. You know, we had to do sightline analysis to make sure that, you know, which property owners would see it. And if there were, you know, if they had a problem with it, we had to do an analysis on sound to make sure that other people couldn't hear it. So, you know, it was not by any means the first in the county, but I don't, the folks that handled that, I was part of the process, but not part of that process. I think they felt as though that was not a fight worth having.
Can I talk? When I drive from Green Bay, I see many very large wind turbines, but they might be are they in Kewaunee County versus Door County?
I mean, there was a field in southern Door County, I thought, but then they might be in Kewaunee, I'm not sure.
Okay. But those are large wind turbines.
Yeah.
I think there is one in Kewaunee. It's on like X or something. I know for sure because I've passed it.
Those are utility facilities that are approved through the Public Service Commission, and that probably trumps the county tower requirements. I'm pretty sure it does because they get a CPCN through the Public Service Commission. But the tower stuff up here has been a big debate because of the cell towers and the Wi-Fi towers, and that's a significant challenge.
We want to be good neighbors.
Yeah.
Okay, we have a question from Jessica. Do you mind unmuting yourself?
All right, so I'm actually I'm Jessica's daughter. I'm actually using her account to watch this.
Awesome.
So my question was, is carbon dioxide the only gas produced at Bjorkluden?
Specifically greenhouse gas?
Yeah.
Probably not. I mean, there's probably, so there's a number of, well, first of all, let's start and say anthropogenic greenhouse gases, right? Because the largest greenhouse gas is actually water vapor.
Yep.
So of the anthropogenic ones, carbon dioxide is by far the largest one that we would produce. There could be some, fugitive, these are, like escaping, like a bad air conditioner that is leaking some freon, for example.
Yeah.
There could be some emissions that way. And that's pretty much it. There's other ways to account for other gases like in concrete and stuff like that, but that's it's sort of already been banked. So I think the biggest one and the one, of course, reducing. Another way to answer your question is to think about what WPS is using to produce energy. Okay, and so there could be other greenhouse gases there. And so if we reduce by we're basically going to eliminate our electricity consumption pretty much. So that means that they won't have to produce those electrons for us. And so any gas, even sulfur dioxide or others that are maybe not the greenhouse gases, but still not gases we want in the atmosphere, those should be reduced.
So another question I have is there like any like methane or like nitrous oxide or like CFCs produced in this?
Right. So the CFCs would be if some of the refrigerants leaked.
Yeah.
But the methane, again, when WPS, if they use natural gas, and I believe they do in some of their power productions, there's going to be some emissions that way, just in terms of when they're bringing the methane in and how it's not always, not 100% of it is burned when you burn it, so some escapes. So, but Bjorklund in particular, we don't use methane. The natural gas line stops, I don't know, 6 miles north of Sturgeon, I think. And we're not like agricultural, so we're not producing a lot of methane that way or nitrous oxide that way. So I think pretty much just CO2.
Okay, thank you.
Thank you.
I'm just going to ask a quick question, and then we can get back to you, Terry. I see your question there. So who installs the turbine and the solar panels? Who do you work with?
A variety of vendors. So we have a lead consultant on this, which is Faith Technologies. Faith is also the one that did the Bubolt's microgrid, and so they would be responsible for procuring the folks that would do a wind. We use Northwind Renewables for the wind turbine that's there. You know, there's a lot of different solar installers. Not all of them would be suited for this scale of a project, but there's a lot of them out there. If anyone's ever gone to MREA, you know, it's just booth after booth of solar installers. The geothermal, now I have a good tip, I'm happy to say, but we were looking at a company called MEP, which is big in the Twin Cities. They are the ones that are putting in a huge solar or a huge geothermal field for Carleton College, like a $40 million geothermal field, just massive. So you know, we'll use our consultants to find that's part of their job, is to find the best people for the best price.
Well, are any of those like Wisconsin companies or even
So, I mean,
Door County people?
right. So a lot of the installers are all locally based. Of course, the panels come from where the panels come. They may be, I don't know that we produce solar panels in Wisconsin. We certainly produce them in the US. The geothermal, you know, again, we had trouble getting people interested in that project. Part of it was just because of COVID, and that's why I say that one might take longer. And so I think we would be have a more thorough vetting process for that one in particular.
Thank you. Terry, if you want to come back on, you're welcome.
Are you making any changes to the building itself in terms of energy conservation?
So the biggest, outside of sort of replacing lighting and upgrading motors and pumps, the biggest change is we'll be using an energy management system to manage the heating and cooling for each of the rooms. But we're not, I mean, the new wing is new enough, it's pretty well insulated. The windows are pretty good. So there's probably some opportunities there, but we're not looking at any conservation measures along those lines. The biggest thing is that if you've been in the rooms, yes, there's radiant floor heating, and then there's also, each room has its own air conditioning unit, kind of like a hotel. Unfortunately, you can have both those on at the same time. So you could be turning your AC on to cool your room down, and it gets down to that crisp 65 degrees you want to sleep. And unknown to you, the heat will turn on at 62 degrees to try to warm the room up. So you can get those two fighting. So one of the major things is to integrate all that into one system so that kind of thing can't happen. We looked at you know, new appliances and things, but everything there is pretty new, and you know, Energy Star. I don't know that Energy Star actually exists for those kinds of big industrial appliances or not, but it was all rated such that we didn't feel it was worth the investment for us.
Are you heating and air conditioning now during unoccupied times?
I can tell you that it is not air conditioned right now, because I was just in there. Large sections are closed off. You know, there's only a few bathrooms are operating. So, and I mean, I can't, you know, they'll have to heat it somewhat. We're not going to mothball it, but it'll probably be like, you know, 50 degrees.
Mm-hmm. Okay.
Okay. I don't have any other questions. So unless you have any final comments, Jeff, I just want to say thanks for everybody for joining us. This was great. I think it worked out well. I hope everybody's, you know, Wi-Fi worked and you heard everything pretty clearly. It was clear on my end. And thank you.
Yeah, well, I want to say thank you for everyone. It was good practice for me. I'll be doing this a lot more in the next few weeks as I'm teaching classes this way. So just seeing how this is gonna work was good. And thank you for the great questions and some of the tips too.
Thank you. And if anybody has any questions or needs to contact Jeff or anything, just please email me at nicole@lnrp.org and I can get you in contact with him. Thank you. Bye, Jeff.
So, you know, I'll record this and then send you a link, okay? Or
Yes.
I'll stop the recording and send you a link.
Please.
Okay, great.
Thank
Really
you.
nice to meet you.
You too.
Thanks,
and here's
everyone.
my cat again.
Good to see you, Chuck. Thanks for the invite.
Bye, everybody.
Glad we could do it.
Yeah, we did it anyway. Would have been nice to be there, I have to say, but
Yeah.
the next time will be sweeter, right?
Right.
Yes. Thank
Take
you.
care.
Thanks.
You bet. Take care.
Bye. Bye. Okay.
Alrighty.